Something went wrong at Starbase, and nobody saw it coming. SpaceX loaded S40 with liquid oxygen. Frost covered the vehicle. Engines were ready. Then, nothing. No roar, no fire. Just a brief flash, and detanking began. 6 Raptor engines. 0 firing. What actually happened? But that's only half the story. Inside Starfactory, a brand new nose cone just appeared, with a mysterious opening, a pipe-like structure, and 6 hidden circular holes that SpaceX has never explained. 2 unexplained events. 1 massive question. Is Flight 13 still on track? Stay with me. Every answer is in this video. Starbase had been quiet for days. Not the kind of quiet that comes before a holiday. The kind of quiet that makes engineers nervous. The kind that means something big is being prepared behind closed doors. Then, on June 24th, everything changed. S40, SpaceX's newest Starship upper stage, was transported to Massey's test site, and the moment it arrived, the clock started ticking. What followed was textbook SpaceX precision. Propellant loading began almost immediately. The tank farm came alive with venting activity. Massive clouds of vapor rising into the Texas sky, visible for miles. Frost began forming across the vehicle's skin. That's not a malfunction. That's exactly what happens when you pump liquid oxygen at minus 183 degrees Celsius into a stainless steel tank. The air around the metal freezes on contact. To anyone watching from the outside, it looked like a rocket ready to breathe fire. The liquid oxygen tank? Fully loaded. Visually confirmed by observers on the ground. The liquid methane tank? Only partially filled, which, depending on the test profile, could mean SpaceX was intentionally limiting propellant load. Not every static fire requires a completely full vehicle. Sometimes you run a partial load test first to reduce risk before going full throttle. Everything was pointing toward one outcome: 6 Raptor engines roaring to life, a static fire that would shake the ground and confirm S40 was ready for Flight 13. That never happened. And what did happen instead raised far more questions than a successful test ever could. Here's exactly what observers reported at the moment of ignition. A brief flash, visible inside the engine section, bright enough to notice, short enough to make you question whether you actually saw it. Then, silence. No sustained roar, no engine startup sequence building toward full thrust, no ground shake, just that single flash. And then detanking operations began. Propellant was drained. The test was over. Now, to understand why that flash matters so much, you need to understand how a Raptor engine actually starts. Think of it like this. Lighting a Raptor engine is not like flipping a switch. It's a carefully choreographed sequence. First, igniters fire. Small sparks that confirm the ignition system is working. Then, propellant flows in controlled stages, building pressure until the engine reaches full combustion. What observers likely saw was the igniter stage, the very first step of that sequence, which means one of 2 things happened. And this is where the story splits into 2 completely different directions. So, which one is it? Because the answer changes everything about what comes next for Flight 13. 2 theories. 1 massive difference. Theory 1. The abort. Something triggered an automatic shutdown before the engines could fully ignite. SpaceX's flight computers monitor hundreds of sensor readings simultaneously during a static fire attempt. Pressure, temperature, flow rates, valve positions, vibration signatures. If even one reading falls outside the acceptable range, even by a fraction, the system aborts, instantly. No human decision required. The computer kills the sequence before any engine can sustain combustion. What could have triggered it? The list is longer than most people realize. A propellant leak anywhere in the feed lines. A flow irregularity that suggests a valve didn't open correctly. A sensor reading that contradicted what the system expected. Or something as simple and as serious as an ignition system anomaly, where the igniter fired, but the combustion didn't develop the way the model predicted. Here's the critical context that the original video touched on but didn't fully explore. S40 comes after the S36 incident. That incident shook SpaceX's testing cadence significantly. After major anomalies, SpaceX has a documented pattern of becoming dramatically more cautious in subsequent testing. They don't just fix the obvious problem, they audit everything connected to it, and they test more conservatively before ramping back up. So if S40 aborted, it doesn't automatically mean something is critically wrong. It may mean the system is working exactly as designed, catching a problem on the ground instead of at 150 kilometers altitude with a full propellant load. Finding a problem during a static fire abort costs SpaceX maybe a week of schedule delay. Finding the same problem during Flight 13 costs them a vehicle, a mission, and potentially months of investigation. That's not a failure. That's the entire purpose of ground testing. Theory 2, the planned cryo test. Here's the alternative, and it's actually the more technically interesting possibility. SpaceX may never have intended to fire all 6 engines during this particular test run. Instead, the entire operation from propellant loading to the brief igniter flash could have been a cryogenic proof test designed to do something completely different. A cryo proof test doesn't measure how well the engines fire. It measures something more fundamental: whether the vehicle's structure, tanks, plumbing, and engine interfaces can survive the extreme thermal and pressure stresses of actual propellant loading. Think of it this way. When you fill a stainless steel tank with liquid oxygen that cold, the metal contracts. Welds stress. Seals are tested. Plumbing connections experience thermal shock that no room temperature inspection can replicate. You only discover certain structural weaknesses when the vehicle is actually cold-soaked at operating conditions. The brief igniter flash in this scenario wasn't the beginning of a failed engine start. It was a planned verification pulse, confirming that the ignition system responds correctly when commanded without proceeding to full engine startup. So here's the question that nobody has definitively answered yet. Was SpaceX trying to fire S40 and something stopped them? Or were they never planning to fire it at all on this attempt? The answer to that question determines whether Flight 13 is on track or quietly slipping toward August. What happens next for S40 and why the clock is ticking? Regardless of which theory is correct, the timeline pressure on S40 is real. SpaceX's internal schedule, based on observable progress at Starbase, points toward completing S40's static fire campaign this week, not next week, this week. That's an aggressive target, and it only holds if either the abort issue is quickly identified and resolved, or the cryo-proof test was already considered a success, and the full static fire is imminent. If S40 completes its static fire campaign on schedule, the vehicle would return to the production site for final flight preparations, tile installation completion, final inspections, integration checks. That process takes time, but it's well understood, repeatable work that SpaceX has optimized across multiple vehicles. But here's the variable that most coverage isn't emphasizing enough. S40 is only half the equation for Flight 13. Booster 20 is the other half. Right now, Booster 20 is inside Megabay, SpaceX's massive assembly facility at Starbase, undergoing inspections and engine installation following its own cryogenic test earlier this month. That booster needs to be ready, inspected, and cleared for flight before any launch date can be confirmed. 2 vehicles. Both need to pass their respective tests. Both need to be stacked. Both need final sign-off. The window for a July Flight 13 launch is real, but it's narrow, and S40's next test attempt, whenever it happens, will be one of the most watched events in spaceflight this month. Don't look away from Starbase, because the next test could happen faster than anyone expects. But while all eyes were on S40, something else was quietly taking shape inside Starfactory, something that nobody fully understands yet. And honestly, it might be the bigger story of the two. Walk into Starfactory on any given day and you'll see Starship hardware in various stages of construction. Tank sections, engine bay components, structural rings. It's organized chaos at an industrial scale. But on June 19th, observers noticed something that didn't fit the pattern. A newly completed nose cone. Bare stainless steel framework. No heat shield tiles, which indicates recent completion. But that's not the unusual part. Cut into this nose cone was a large, reinforced opening. Not a standard port. Not a sensor interface. Something significantly larger and more structurally reinforced than anything seen on previous Starship nose cones. Beneath that opening sat a highly reflective metallic plate. And above it, several circular and square openings arranged in a configuration that doesn't match anything on the existing Starship fleet. Then, on June 23rd, just 4 days later, the hardware evolved. SpaceX added what appears to be a pipe-like structure extending outward from that opening. At the end of the pipe, a ring lined with numerous small holes arranged in a precise pattern. The reflective metallic plate beneath had been removed, revealing 6 circular openings hidden underneath that weren't visible before. 6 hidden circular openings. That's not a coincidence. That's engineering with a specific purpose. And the location of all these modifications makes this even more interesting. They sit in the upper portion of the nose cone, near the lower region of the liquid oxygen header tank. That's a structurally significant area. It's not where you put secondary instrumentation or standard access panels. You put hardware there when you need something to happen near the top of the vehicle during flight or during docking operations. So what exactly is SpaceX building? 3 theories. 1 truth nobody has confirmed. SpaceX has said absolutely nothing about this nose cone. 0 official comment, which historically means one of 2 things. Either it's too early to announce, or it's something sensitive enough that they're keeping it quiet until it's closer to operation. That silence forces us to work from the evidence, and the evidence points in 3 distinct directions. Theory 1. The Starship tanker docking system. SpaceX's plan for sending humans to the moon, and eventually to Mars, depends entirely on orbital refueling. The concept is straightforward in theory, but extraordinarily difficult in practice. You launch a Starship. You launch multiple tanker Starships carrying propellant. Those tankers dock with the primary vehicle in orbit and transfer their propellant. The primary vehicle, now fully fueled, continues to its destination. SpaceX has previously shown the propellant transfer interface, the hardware that actually moves the fuel between vehicles, located beneath the payload door area of the Starship. That's on the side of the vehicle. But the hardware on this nose cone isn't positioned like a fuel transfer interface. It's positioned like a docking mechanism, something that would physically connect 2 Starships together and hold them stable during propellant transfer. Think of it like a physical handshake between 2 vehicles in orbit. You can't just pump fuel between 2 spacecraft that are loosely floating near each other. You need a rigid structural connection that keeps them aligned, prevents relative motion, and provides a sealed interface for propellant to flow. The ring with numerous small holes? That could be exactly that kind of docking ring, designed to mate with a corresponding interface on another Starship, lock in place, and create a stable connection in the vacuum of space. If this theory is correct, this nose cone could represent the first physical hardware for orbital propellant transfer, one of the most critical technologies SpaceX needs to master before any deep space mission is possible. And SpaceX is reportedly targeting orbital refueling demonstrations in late 2026 or early 2027. The timing of this nose cone's appearance aligns almost perfectly with that schedule. Theory 2, the Human Landing System docking port. This theory carries enormous implications, not just for SpaceX, but for NASA's entire Artemis program. The Human Landing System, or HLS, is the Starship variant that NASA has contracted SpaceX to build for landing astronauts on the moon. But here's the part that most people don't fully understand. HLS Starship doesn't launch from Earth fully fueled. It can't. Earth's gravity and atmosphere make that impossible with current rocket technology. Instead, HLS Starship launches, reaches orbit, receives propellant from multiple tanker missions, then departs for the moon. At the moon, it receives astronauts who transfer from NASA's Orion spacecraft. That transfer requires a docking interface, and many HLS concept designs, including internal NASA documentation and SpaceX concept artwork, place that docking port near the top of the vehicle, which is exactly where this mysterious hardware is located on this nose cone. There's another clue hiding in plain sight. The area surrounding these modifications features markings that differ from those seen on other Starship variants. And if you look at HLS concept artwork that SpaceX has released over the years, windows are often depicted in roughly that same region of the vehicle. Windows near a docking port, a specialized interface at the top of the vehicle, hardware that doesn't match anything on standard cargo or satellite deployment starships. The HLS connection is compelling. But here's where it gets complicated. If this is HLS hardware that only now entered production, the timeline raises serious questions. Artemis 3, the mission that would actually use HLS Starship to land humans on the moon, is currently scheduled for 2027. Building flight-ready HLS hardware now, from scratch, would be extremely tight for that schedule, which leads to a more nuanced possibility. This might be a demonstration vehicle, not the operational lunar lander that will carry astronauts. Instead, a test article designed to demonstrate docking capabilities, validate the interface design, and support development before the flight version is built. Previously leaked images suggest more advanced HLS hardware is already under development at Starbase. If that's the case, this nose cone could be a parallel development path, a demonstration unit being built alongside the operational hardware. Theory 3. HLS maneuvering thrusters. This is the theory that gets the least attention but might be the most technically interesting. Standard Starship uses Raptor engines for primary propulsion and smaller thrusters for attitude control. But the human landing system faces a completely different set of demands. Landing on the moon requires precise maneuvering at low altitude with fine thrust control. You can't use full Raptor engines for terminal descent. They're too powerful and would blast lunar regolith in ways that could damage the vehicle. The HLS needs specialized maneuvering thrusters that can provide precise, controllable thrust in multiple directions for landing, ascent, and attitude control throughout the lunar mission. The location of this hardware, near the lower region of the liquid oxygen header tank in the upper portion of the nose cone, could be consistent with a thruster installation designed to provide attitude control during lunar approach and landing. The 6 hidden circular openings could be thruster ports. The pipe-like structure could be propellant feed lines. The ring with small holes could be part of a thruster array or propellant distribution manifold. 3 theories. 3 different implications for the future of Starship and the Artemis program, and SpaceX has confirmed exactly none of them. The timeline that ties everything together. Here's what makes both stories, S40's test and the mystery nose cone, more significant when you look at them together rather than separately. SpaceX is not building one future. They're building multiple futures simultaneously. S40 and Flight 13 represent the near-term future, proving that Starship can fly reliably, recover both stages, and begin operating as a real launch system. Every static fire test, every successful flight, every catch of a returning booster builds the foundation of operational confidence. The mystery nose cone represents the long-term future. Whatever specialized variant SpaceX is developing, it exists because the basic Starship is mature enough that they can now invest engineering resources into specialized versions for specific missions. You don't build an orbital refueling docking system or an HLS docking port if you're not confident your baseline vehicle works. The existence of this hardware is itself a statement. SpaceX believes Starship is ready to evolve beyond the prototype phase, and the timing supports this reading. If this nose cone continues development at its current pace, the vehicle it belongs to could be completed and stacked before the end of 2026. That aligns directly with 3 critical milestones: orbital refueling demonstrations targeted for late 2026 or early 2027, the current Artemis 3 schedule, and the broader SpaceX goal of making Starship a multi-mission platform rather than a single-purpose rocket. There's one more dimension to this that most coverage is missing entirely: Florida. While Texas was the center of attention this week, something equally significant was happening 1,600 kilometers away at SLC-37 in Florida. One of the giant tower arms, the chopsticks arm, was transported to the SLC-37 launch site. It passed NASA facilities. It passed LC-39A, where SpaceX already operates a Starship launch site. and it arrived at SLC-37, where SpaceX is building a second Starship launch complex from the ground up. This is not a minor logistics update. This is a fundamental shift in what Starship is about to become. Right now, Starship launches from one site, Starbase in Texas, one tower, one launch mount, one flame trench. If that infrastructure needs maintenance, or if SpaceX wants to increase launch frequency beyond what a single site can support, there's no backup. SLC-37 changes that equation entirely. With two launch sites, Texas and Florida, SpaceX gains redundancy. They gain the ability to process multiple vehicles simultaneously. They gain access to different orbital inclinations that are easier to reach from Florida's latitude. And they gain the infrastructure foundation needed to approach their long-term goal of up to 120 Starship launches per year from Florida alone. 120 launches per year from a single state. That's more than 2 launches per week, every week, without interruption. But here's where a significant problem enters the picture, and it has nothing to do with rockets. The $1 billion problem nobody is talking about. NASA's Office of Inspector General just released a report that should be making bigger headlines than it is. The core finding, America's launch infrastructure at Kennedy Space Center and Wallops Flight Facility is running out of capacity, and it's aging faster than it's being upgraded. The numbers tell a stark story. NASA-supported launches in Florida increased from 31 in 2020 to 109 in 2025. That's a 252% increase in 5 years. Wallops grew from 3 to 17 launches over the same period, and by 2030, NASA projects a further 150% increase across both facilities. Here's the part that most coverage glosses over. The bottleneck isn't the launch pads themselves, it's everything else. Hundreds of kilometers of roads that were designed for Apollo-era traffic loads. Electrical systems that weren't built to support simultaneous operations by multiple commercial operators. Nitrogen infrastructure, the pressurized gas that purges systems, operates pneumatic controls, and serves dozens of critical functions during launch operations. They cannot simultaneously support both an SLS launch and a New Glenn launch without creating conflict. That last point deserves to be underlined. NASA's current nitrogen infrastructure cannot support 2 major launch operators running operations at the same time. If SLS needs a nitrogen purge and New Glenn is preparing for launch simultaneously, one of them waits, potentially for weeks. With SpaceX planning to run both LC-39A and SLC-37 for Starship, with Blue Origin operating New Glenn and preparing for Blue Moon, with ULA still flying Vulcan, the shared infrastructure bottleneck isn't a future problem. It's a present problem that's going to get dramatically worse within 18 months. NASA's proposed solution requires at least $1 billion in upgrades, transportation networks, electrical systems, industrial gas infrastructure, new funding models that would require commercial operators to contribute directly to the cost of expanding shared facilities. Is that $1 billion worth it? Here's the argument that the original video presented, but didn't fully make. The question isn't whether the investment is worth it in isolation. The question is what happens if the investment doesn't happen. If launch infrastructure becomes the bottleneck, SpaceX can't hit 120 launches per year from Florida, no matter how reliable Starship becomes. Blue Origin has already warned publicly that a single launch complex may not be sufficient for their future operational needs. That warning is a preview of what every major operator will be saying within 2 years if the infrastructure problem isn't addressed. $1 billion sounds like a large number. Against the alternative, a launch industry bottleneck that delays moon missions, Starship scaling, and America's position in the global space race, it starts to look like a bargain. But with NASA budgets already under pressure and multiple programs competing for funding, the timing of this investment is genuinely uncertain. And uncertainty in infrastructure spending creates ripple effects across every program that depends on those facilities. The rockets are ready to fly faster than ever. The ground beneath them might not be. What all of this means, the bigger picture. Step back from the individual stories. S40's mysterious test, the unknown nose cone, the Florida tower arm, the $1 billion infrastructure warning, and a single clear pattern emerges. Think about what happened in just 1 week. S40 was transported, loaded with propellant, and tested, with results that remain deliberately ambiguous. A nose cone with hardware nobody has seen before appeared inside Starfactory. A chopsticks arm was physically moved to Florida. And a federal report confirmed that America's launch infrastructure is being pushed to its absolute limits by the pace SpaceX has already set. 1 week. 4 major developments. 0 slowdown. That's not normal. That's not even close to normal for the aerospace industry, an industry where major programs routinely measure progress in years, not weeks. But here's the twist that most people miss when they focus on the exciting hardware stories. Speed without infrastructure is a dead end. SpaceX can build Starships faster than any rocket in history. They can test them, modify them, and relaunch them at a cadence that makes traditional aerospace look like it's operating in slow motion. But if the ground infrastructure, the roads, the power systems, the nitrogen supply lines, the launch towers, can't keep pace, the rockets sit, ready, waiting, going nowhere. That's the real tension at the heart of every story this week. And beyond Flight 13, the mystery nose cone tells us that SpaceX is already designing the Starship that comes after the Starship we know today. Whether it's a tanker docking system, an HLS docking port, or maneuvering thrusters for lunar operations, that hardware represents a version of Starship that will be more capable, more specialized, and more mission-critical than anything currently flying. The gap between where Starship is today and where that nose cone is pointing, that gap is closing faster than anyone outside of SpaceX headquarters fully appreciates. The detail everyone overlooked and why it matters. There's one specific detail from this week's events that deserves more attention than it received. The markings on that mystery nose cone. Observers noted that the area surrounding the modifications features markings that differ from those seen on any other Starship variant currently in production or flight. Not slightly different, noticeably different. In SpaceX's manufacturing process, external markings and reference points serve specific engineering purposes. They indicate measurement references, structural zones, system boundaries, and interface locations for ground support equipment. Different markings in a specific zone mean the engineering team defined that zone differently from everything that came before. You don't create new markings on a new Starship variant unless that variant has fundamentally different systems in that area. Different systems mean different mission requirements. Different mission requirements mean this isn't just a slightly modified standard Starship. It's a purpose-built variant designed from the inside out for something specific. Combined with the location, upper nose cone, near the liquid oxygen header tank, and the hardware evolution observed between June 19th and June 23rd, the picture becomes clearer, even without official confirmation. SpaceX added hardware, then modified it 4 days later. That's an active development cycle happening in real time, visible to anyone watching. They're not installing finished, finalized hardware, they're iterating, testing configurations, figuring out the exact design as they build it. That's actually significant information. It tells us this vehicle is not close to flight ready. But it also tells us the development is active and moving quickly, not sitting in a design phase on someone's computer screen. If the pace of visible hardware changes continues at this rate, the configuration of this nose cone could be finalized within weeks. And once configuration is finalized, production accelerates rapidly toward completion. Keep watching Starfactory. The next visible change to that nose cone will tell us more than any official announcement. The question that defines what comes next. Everything this week points toward a single defining question, and it's not the one most people are asking. Most people are asking, will Flight 13 launch in July? That's the wrong question, because whether Flight 13 launches in July or August or September doesn't fundamentally change the trajectory of what SpaceX is building. A month's delay on one flight in the context of a program targeting 120 annual launches is noise. The right question is this: is SpaceX developing Starship fast enough to meet the demands that are coming? Orbital refueling, human lunar landing, Mars missions, military applications, satellite deployment at scales never attempted before. Each of these requires not just a working Starship. They require a mature, reliable, high-cadence Starship operation. But the NASA infrastructure report throws a real variable into that optimistic picture. The ground systems that support all of this, the roads, the power, the gas supply, the shared facilities, are already being strained by the launch cadence SpaceX has achieved today. The cadence SpaceX is targeting for 2027 and 2028 would break them without significant investment. That $1 billion upgrade isn't optional. It's load-bearing for everything else. And here's the uncomfortable truth that nobody in the industry wants to say directly. The biggest risk to SpaceX's long-term launch cadence ambitions is not rocket technology. It's not regulatory approval. It's not even funding. It's concrete. Steel, pipes, roads, power lines, infrastructure built in the 1960s stretched far beyond its original design parameters, serving a launch industry that nobody in 1969 could have imagined. Starship is ready to fly faster than the ground can handle. That gap between what the rockets can do and what the ground can support is the real story of 2026. And it's going to get louder before it gets quieter. S40's next test will answer one question. The mystery nose cone will reveal its purpose eventually. Flight 13 will launch when it launches. But the infrastructure question? That one doesn't get answered by a single test or a single launch. It gets answered by policy decisions, funding allocations, and construction timelines that move at a completely different speed than SpaceX's engineering teams. The rockets are outrunning the ground beneath them, and that's the most unexpected development of all. 2 events, 1 week. 0 official explanations from SpaceX. That's exactly why analysis matters more than announcements. If this breakdown gave you a clearer picture of what's actually happening, hit like, drop your theory on the nose cone in the comments, and subscribe to The Space Brief for more. Tap the screen. Something worth watching is right there.